All right, in this video, we are going to start our discussion with the definition of random variables and discrete distributions. So let's start with the concept of random variable, and let's start with the simplest possible experiment, flipping a coin. The result is going to be either head or tail. So let's just define a mapping, whatever you want to call it, a mapping, a function, that every time that a flip of a coin is head, this function is going to show us 1, and every time that it's tail, this function is going to show us 0. So the mathematical way of writing that is x of head is equal to 1. It means if you feed head to x, it is going to return 1. And x of tail is equal to 0, meaning if you feed tail to x, it's going to give you 0, right? What we just did, we defined a random variable called x. What is a random variable? It's just numerical description of the outcome of the experiment, right? Um, Let me put it as simple as it gets. Imagine we are lazy, and instead of saying, "Oh, I flipped a coin and result is head," we are going to write x equal to 1. And instead of saying, "Oh, I flipped a coin and the result is tail," we are going to say x equal to 0. All right, so it's just at least for the time being, it's a we define it for convenience to make it easier for us to write on paper. All right, that's as simple as it gets. So here's another one, tossing a coin twice, and this time I define random variable in a specific way. I define random variable y as number of heads. See, now it's getting a little bit more exciting. Number of heads. Well, and tail doesn't have any heads, so y is going to return 0. Head tail is going to return 1. Tail head is going to return 1, and head it's going to return 2, right? In other words, y of head is 2, y of head tail is 2, 1, y of tail head is 1, and y of tail is equal to 0, right? So in other words, random variable is just a numerical function of the that takes every outcome to a numerical value. All right. Now, I talked about the definition, so let's see if we can define random variables differently. Yes, we can define random variable pretty much the way you like, right? For example, if I'm rolling a die twice, or we roll 2 dice, okay, then you can define random variable x as number of 4s. You can define random variable y as sum of 2 rolls that is going to go between 2 all the way to 12. You can define random variable z as a first roll to the power of 7. Well, but oftentimes we do these things. We define random variables so that they are useful. All right. So we are going to define specifically, now that we know we can define random variables the way we like, in any way we like, we are going to define them in a way that they are useful. All right. So let's move on. I talked about all of this. So a function of a random variable is going to be a random variable itself. With random variable, we are going to define a mean, or the same as average, or variance. And of course, with variance comes with standard deviation as well. You can condition it and find conditionals. You can work on independence and so on and so forth. This is just the beginning, all right? So there are 2 types of random variables, discrete and continuous. Our focus for now is at discrete random variables. You should be able to count them, all right? So it doesn't have to start from 0 or 1. It could start from any number, but you should be able to count them, all right? And continuous ones, there are uncountable number of them. So we are talking about their range. So we are going to focus more on details soon. All right. We talked about the definition of random variable, discrete, continuous, and random variable. From this point on, we are going to show that with RV, R dot V, capital R, capital V, and oftentimes random variable, we show them with capital letters, X, Y, Z, W, K, in capital letters, and the values that they take, we are going to show them with corresponding lowercase numbers. All right. Let's move on. Again, why do we define this if we cannot connect it to probability, right? So we will. There's a new concept called probability mass function, or we are going to show that be PMF, all right? So previous example, tossing a coin twice, random variable y defines as number of heads. Tail is going to, y is going to return 0. Head tail and tail head is going to return 1. We saw that. And head is going to return 2. Then what is the probability of y0? Well, probability of y0 is equal to probability of tail. That is 1/4. What is the probability of y equal to 1? Well, that comes from two different outcomes. One of them head tail, the other one is tail head. So it's going to be 1/4 plus 1/4. That gives us 1/2. And probability of y equal to 2 is equal to probability that you get head. Then it is going to be equal to 1/4, right? The way we like it is this: probability that y equal to 0, y1, and y2. See, this is easier to write than writing probability of head, tail, and tail head. All right, again, for time being, it has been just for convenience. Whatever probability function that I defined, this is a probability, we call that probability mass function. Imagine those values of 0, 1, and 2. We have a mass or weight of 1/4 on 0. We have mass or weight of 1/2 on 1. And we have mass or weight of 1/4 on 2. So this one, again, what I just explained is also shown right here. All right. So I think I explained all of this. Oftentimes you are going to see this probability of otherwise or OW0. It means this is just being mathematically correct, that it takes 0, 1, and 2 with positive probability, and any other value has a mass or weight or probability of 0. Well, from probability theory from previous lectures, we know that sum of probabilities must be between 0 and probabilities must be between 0 and 1, and sum of probabilities must be equal to 1. So let me record another video to continue this topic.